This is PreCalculus 12, Chapter 1.3. We're going to be looking at graphing polynomial functions, and we're just looking for some general details. We can use our graphing calculators to make some conjectures about higher degree polynomial functions, or we can use Desmos. It's a little bit faster. However, be warned, you still need to learn how to use a graphing calculator for tests because Desmos won't be allowed on your tests. Okay, let's look at even degree polynomials. The degree is the exponent of the largest power of a polynomial. So if we look at this function, 3x squared plus 5x cubed minus 6x to the power of 4 is 30. So this one's not in order, but our highest degree comes from negative 6x to the 4th. So the degree is 4. Okay, let's look at some graphs. There's 4 factors here. So this is actually x to the power of 4. Here we have x. We have x to the power of 4, but we have a coefficient here. So this is y equals negative 2x to the power of 4. And there's no coefficient here, so it's implied that it's 1. There's other terms as well. And here there's other terms as well. But it's easy to calculate the first term, and it's also easy to calculate the last term. The c is 3 times 2 times 1 times negative 1. So the c is negative 6. The constant term here is 3 times 2 times 1 times negative 1 times a negative 2. So this is 12. And the c is also our y-intercept. So you can see our y-intercept here is negative 6. Our y-intercept here is 12. Okay, other features. How does the degree affect the shape? Okay, the shape, we have one valley, one hill, another valley. So that's 3 hills and valleys. Here we have hill, valley, hill. Okay, so degree is greater than the number of hills and valleys. And how does the leading coefficient affect the shape? Okay, so we can see that it starts at the top, comes down, and goes up to the top again. So that's, in general, very generally, it's concave up. Here it starts at the bottom, comes up, very generally, and then goes down. So again, very generally, it's concave down. So we can write that very generally. Concave up. Positive. Down. It's negative. Okay, do repeated roots have effect? How would you describe the range? Okay, so we look at this function. We have x plus 2, x plus 2, x minus 1, x minus 2. So this is a repeated root. And it occurs at x equals negative 2. So that's here. And we look at this one, x plus 3, x plus 1, x minus 2, x minus 2. X equals 2. And that occurs there. If we look at the root at 1 and 2, it goes right through the x-axis, Here, it bounces off the x-axis. At negative 3, goes through, negative 1 goes through, and at 2, it bounces off the x-axis. So we write two repeated roots bounces off x-axis. How would you describe the range? Well, we can see that we have a global maximum. Here we have a global minimum. It doesn't get any lower than this, doesn't get any higher than this. So has an absolute or global min or max. Okay, but it doesn't have both. It has one. And the range is not all reals. Let's take a look at odd degree polynomials. Okay, so roughly this is y equals x cubed, x. And again, we can look at our constant term. So 1 times 0 times negative 2 is 0. Very generally, we have negative 2, our coefficient, x, so that's x to the power of 5. And our constant term is 3 times 2 times 1, that's 6, times negative 1 is negative 6, times negative 2 is 12, times another negative 2 is negative 24. Okay, and we can see that that's our y-intercept here, negative 24, and we can see our y-intercept here is 0. Okay, but how does the degree affect the shape? This is odd, this is odd. So we don't talk about concavity here. So very generally, how does the degree affect the shape? Okay, so we have hill, valley. So that's two hills and valleys. Here we have 1, 2, 3, 4 hills and valleys. So again, it's less than the degree. So same as even answer. Degree is greater than number of hills and valleys. How does the leading coefficient affect the shape? Okay, very generally, it's like a line. It starts in quadrant 3, ends in quadrant 1. Quadrant 3 ends in quadrant 1. Here, again, it's very generally like a line. Starts in quadrant 2, ends in quadrant 4. Okay, so a line that has positive slope starts in this quadrant, ends in this quadrant. A line with negative slope starts in quadrant 2, ends in quadrant 4. Do repeated roots have an effect? So this time I've used a graphing calculator instead of Desmos. By the way, if you want to use Desmos, it's just desmos.com. It'll get you to this page, then you click on Start Graphing, and then you can just type the formula for your equation. Okay, so we have x plus 2, x plus 1, x minus 2, x minus 1, and x equals 2 is a repeated root, and we can see that it bounces off. This is not a repeated root, and you can see it goes through, goes through, goes through. So we have x plus 1, x plus 1, x minus 2, x minus 2, x minus 3. So we can see x equals negative 1, we have a repeated root. X equals 2, we have a repeated root. x minus 3, it's not repeated and goes through. So 2 repeated roots bounces off. And how would you describe the range? Well, it's all reals, okay? Because if a line has a slope, the range is all reals. So there is no global min or max. But we can have local min or max. Okay, so if we look here, this is a local minimum because it's smaller than all the points around it. We have a local maximum because it's bigger than all the points around it. Okay, so if you have a hill or a valley, you're going to have a local min or max. One thing that helps us with examining shapes is to adjust the window. Sometimes you will need to zoom in or out. And here's a tip. You can start with the domain on the calculator as negative absolute value of the constant term to the absolute value of the constant term. And sometimes you also have to set the range to be negative absolute value of the constant term to the absolute value of the constant term. So if we look here, it's a little bit different. We factor out the x and we get -2. So we go from -2 to +2. That way we can see all the features of the graph. Here, our constant term is -24, and we need to set -24 to 24 to see the vertical. It's much smaller for the horizontal, but if you start with the window there, that will help you find it. On Desmos, it's a little bit tricky to have your horizontal axis be a different scale than your vertical axis. So let's just take a look at that problem. Y equals -2, x plus 3, x plus 2, x plus 1, x minus 1, and x minus 2. Okay, we've got all the roots in this domain, and we have to go to settings. So we can make this smaller, and what we'd like to do is make this bigger. Okay, and so now we have a different scale for the x and y. So you just have to go to settings. Takes a little bit more work there, but it's not too bad. Okay, so the note here is use this as a starting point. Then zoom in or out until The hills and valleys are well defined. And here's a few questions to think about when you're examining the polynomials. Think about the number of hills and valleys and how they relate. Is it possible to have 2 hills and 1 valley? Is it possible to have 2 hills and 2 valleys? 1 hill and 2 valleys? 3 hills and 1 valley? If the degree is 5, can we have 2 hills and 2 valleys? 1 hill and 2 valleys? 3 hills and 3 valleys? You should pause it now to think about these questions and then press play and listen to the answers. Okay, yes, it is possible to have 2 hills and 1 valley, so you just draw these things. So hill, valley, hill. 2 hills and 2 valleys. Yes, again, you can just draw hill, valley, hill, valley. 1 hill and 2 valleys. Yes. So instead of starting with a hill, we have to start with a valley. Valley, hill, valley. 3 hills and 1 valley. No, we can't do this. If we start off with a hill, valley, hill, we can't have another hill without another valley. So that's not possible. If the degree is 5, can we have 2 hills and 2 valleys? Yes. So we have 2 hills, 2 valleys. And this is a degree 5 function. Okay, it starts in quadrant 3, ends in quadrant 1. 1 hill and 2 valleys. Okay, here we had 1 hill and 2 valleys. Well, this is concave up, so it can't be a degree 5 function. So no, not odd. This is even. If we're talking about concavity, it's an even degree polynomial. 3 hills and 3 valleys. Okay, 3 hills. 1, 2, 3. 1 hill, 1 valley, another hill, another valley, another hill, another valley. Okay, so this is odd, but degree is greater than 5. Okay, so this is at least a degree 7 function. And that completes this lesson.